Welcome to my lecture. Today we are going to solve one interesting problem from International Math Olympiad 1960. So it says that determine all three-digit number n having the property that n is divisible by 11 and n by 11 is equal to the sum of the square of the digit of n. So if n has three digits, let's say A, B, C, 100th position is A, 10th position is B, and unit position is C, then A square plus B square plus C square is equal n over 11. And n is divisible by 11. So this is very interesting problem, and there are many solutions in the internet. You will find it. But there are many suggestions that we can go for the trial method. So trial method means three-digit number. So from 100 to 999, and among these 81 number is divisible by 11. So we can go for all these 81 number and check it that we satisfy this condition. Sum of the square of the digit is equal n over 11. So that's one process. But here I'm going to solve a different way. So here is that smallest digit number divided by 11 is equal 110, which is 11 multiplied 10. And the largest three-digit number divided by 11 is 990, which can be written as 11 multiplied 90. So therefore, this are two digits. So therefore, we can see here that the n, since n is divisible by 11, so it can be expressed as n 11 multiply a two-digit number, because you see that maximum is 90, minimum is 10. So a two-digit number between 10 and 90. So we take that, since two-digit number, we can write it 10a plus b, where a is from 1 to 9 and b is from 0 to 9. Okay. So this is the form of n. So now if we multiply this, we can write it n as 100a plus 110a plus 11b. So this is we write it as 100a plus 10a plus b plus b. So we write it in the form 100th position, 10th position, and unit position. So therefore, the digit for n is a plus b plus and b. So by the conditions is here, sum of the square will be a square plus a plus b whole square plus b square. And what about n over 11? So this will be 10a plus a. So now by the given condition, this a square plus a plus b whole square plus b square equal 10a plus b. So after simplifications, you just open the bracket and simplify and collect a in the quadratic equation of a. Then we have the solution a equal 5 minus b plus minus square root 25 minus 8b minus 3b square over 2. So here b, we take it from 0 to 9, and we will see that for which value a will come an integer from 1 to 9. So clearly for certain b, this will be negative. So therefore, that are not acceptable roots. And also, if the square root is not, if the square root is not proper, means it is not calculated, give the integer, that root also be not considered, because a is an integer. So we must have this is either perfect square root or 0. So for that we will go by one, values of b and we'll check it which values of b is acceptable. So we take it now. B is equal different value from 0 to 9. And we see here for b is equal 0, a will be 5 plus minus square root 5 over 2. So square root of 25 is 5. So we got it a equal 5 and 0. And if we take b is equal, and a cannot be 0, so a will be 5. And then if we take b equal 1, then we will have 4 plus minus square root 14, so which is not an integer, so therefore it's not acceptable. Now if we take b is 2 or more, then we just calculate first for 2, then we are getting that for b equal to, we have this root, and then this is become complex root. So therefore for b 2 or more, this square root is become negative. Inside the square root it's a negative number, so it will always complex root, so therefore not possible. So finally we have that a equal 5 and when it is b equal 0. So if we substitute it here, then we are getting n is equal 100 multiply 5 plus 10, 5 plus 10, and this will gives you 5, 5. So we have one number is 550. Now we consider the second case. So in this case, let's n can be expressed as 3-digit 100a plus 10b plus c. Then we, since n is divisible by 11, so we'll try to make it a factor of 11. So when you make it a factor of 11, we are getting 99a plus 11b, and then we have here extra term a minus b plus c. So this is divisible by 11. This is also divisible by 11. Now n to be divisible by 11 if a minus b minus c is equal 0 or multiple of 11. So if a minus b plus c is equal 0, then it will be almost same as the first cases we discussed it. So we are not taking a minus b plus c is equal 0. We are taking a minus b plus c is equal 11. So now the question may be that why not 22 or 33? Now we will see that here the values of a, b and c will be from 0 to 9. Even a cannot be 0. So then if we substitute it here, a maximum value is 9, c maximum value is 9. So 9, 9, 18, and maybe b from 0 to 9 if you substitute. So the maximum value it will come 18. So therefore the number should be 11 only, then it will be divisible by 11. So we take a minus b plus c is equal 11. Then from there we get c equal 11 minus a plus b. Again we convert it into two variable, and then n over 11 from here, because it is 11. So if you simplify that, then n over 11 will be 9a plus b plus 1. So here you see that the digit for n is a, b, and 11 minus a minus b. So this will gives us now the formulation a square from here, b square, and 11 minus a plus b whole square, and this is equal 9a plus b plus 1. And then after simplification, if you solve it for a, you will get it 31 plus 2b plus minus square root 1 minus 44b minus 12b square over. So now here if you see that inside the square root, so we can say that here this is real when b is equal 0. Any other cases it is complex root. So therefore we take b is equal 0, and thus we will get 2 roots 31 plus minus square root 1 is 1. So if you simplify it, then we got it a equal 30 over 4 or a equal 32 over 4 equal 8. Now 30 over 4, it is not an integer, so it is not acceptable. So therefore we have now the case is here, second case, a equal 8 and b equal 0. So this will gives us n is equal 100 multiply 8 plus 10 multiply 0 and 11 minus a, so 11 minus 8 plus b. So if you simplify, this is equal 803. So we have two number, one is 550 and another one's 803. And if you want to verify it, then you can just verify this way. So 8 square plus 3 square, get it here, 8 square plus 3, this is equal, you have here 64 plus 9, 70, and 803 divided by 11. So this is divided by 11. So this is also 70. So therefore it's 12. So same way you can validate the 5055